I'll give the talk in English, so like the other talks. And this in fact won't be a workshop. This will be a live coding session. So I understand that this is after lunch, so just lay and listen, okay? I hope that you don't fall asleep. It's the only thing I ask for. So I'll try to keep it entertaining, at least for the first 20 minutes, and you can sleep, okay? So this is maybe the hardest workshop of all, because I will be exploring some little advanced topics in Python, particularly one complicated topic that one finds when starts writing complex Python code, which is the GIL. Who knows what the GIL is? One? If I say global interpreter lock, the global interpreter lock is the GIL, okay? But it's one of those things that once you become a little more proficient in Python, you find. And I will try to make you understand that, okay? And the implication it has when you try to program distributed systems and high-performance systems. So this is Python for distributed systems. And in reality, it should be Python for high-performance distributed systems. It means that we will make some things looking for performance, not just distribution. And you will see what are the mental processes I follow to try to make things perform well. Okay? So about me, I'm a PhD in aerospace engineering, and I've worked with supercomputers a lot and dealt with lots of data. Not right now. And something curious in my profile is that in some cases I wired the supercomputers I used. Something that was very painful but very entertaining too. And nowadays I build distributed systems for a living. And it's a kind of niche thing. There's not a lot of people building distributed systems for a living. And here you have my Twitter account and my website. In my website there's a chat. Sometimes we hang out there and we talk about, I don't know, high performance distributing thing stuff, something like that. So we can hang around there when you want. So, about high-performance distributed systems, what they are. Not this, definitely not this, okay? I know that there's people perfectly happy with things like this. Sometimes what it's really complicated in your work is the algorithm, is the computations you make, and then you can perfectly run them in a cell phone. I mean, these things do amazing things. But these things are, for nowadays, they're fine. Some cell phones have 2 gigs of memory, but however, they're small. And particularly if you want to work with big data or you need more than one processor. Some years ago, that was said that, okay, you can write code that doesn't perform well. Just wait that the processor is fast so we can catch up. Nowadays, it is, okay, so just write multi-core code, so when the processors will have enough cores to run what you want, it will be fine. Now, it's not enough, okay? Sometimes you need this. It's not the problem for everyone, and I understand that's not the problem for everyone, but when you find yourself needing to use hundreds or thousands of those, you find yourself into trouble, okay? So this is maybe a talk for the future you that in maybe one day has to use a lot of resources, okay? You can, of course, use a prepackaged thing. This is a photo I found when I looked at a big data ecosystem. Those are some, not all of them, some of the packages that you can use for big data. That is now a great topic. And you can use something that is already packaged. You can use a Spark, you can use Think, you can use Impala. There are a million of things, and there are a million of companies that they will do that for you if you have enough money. But let's try to do something from the ground up in 1 hour and a half. So we have 1 hour and a half. We'll try to build something in 1 hour and a half, and let's be ambitious, okay? Let's build something that can scale, okay? And for that, if you want to make money out from it, you need something like the unicorn idea, something that can let you make a lot of money, okay? So I thought that maybe the unicorn idea here are the fractals. Who knows about fractals? Okay, let me make the reverse question. Who doesn't know about fractals at all? It doesn't sum up to 100. Come on. I mean, there's people that's not. Are you already asleep? Okay, a fractal is just a mathematical construct. Okay, this is the Julia set. The Julia set is one of the most complex structures that is known to man. Okay, if you zoom in enough, you can find an elephant. Okay, so these things, you see that there's patterns that are repeated. Not all the patterns are equal. You can actually find anything in the Julia set. Okay, the Julia set obeys that formula there. It's a very, very simple formula. And it was discovered by Pierre Fatou and Gaston Julia at the beginning of the 19th century. And it made the mathematicians crazy. I mean, they loved it. They still love it. Okay? They love the fact that such a simple formula produces such an amount of complexity. Okay? Gaston Julia, the poor guy, lost his nose in the World War I, so he spent all his life wearing a patch in the face, which is kind of maybe, it really builds your personality, I think. Okay, so, but the interesting thing about fractals is that they are kind of there in nature. This is a turbulent flow. This is, in fact, a Rayleigh-Taylor instability. You find something that resembles a fractal there. But the most usual photo to illustrate what a fractal is this one. They use it to say that fractals are everywhere. No, they're not. There are things that look like fractals, things that are self-similar that look like fractals or resemble fractals that exist in nature, okay? But they're not fractals. They look like fractals, okay? So let's make a Julia set. And making a Julia set is very easy. So you open Emacs. Who here uses Emacs still already? 1, 2, 3 people out of... Come on. Are you all using PyCharm and all this modern stuff? VI. I have 10 fingers. I can use Emacs. So just start from scratch. So I will make something that is called Julia set.py, okay? And if you've learned something up to now, you will know that the most important module of Python is NumPy. And you import it like this. And Julia set. The Julia set only, if you remember the formula, depends only on 2 things. So it depends on the z, which is the variable, a constant c. And then I will play a trick. That's to plot it. And then it is a loop as easy as this. So for n in range max iter, then z, if I will tell you about this trick later, okay? If apps z is bigger than 2, return n, and if it's not bigger than 2, if not bigger than 2, so say you iterate z to the power of 2 plus c. C, and it's as easy as this, and then you return it. And this is the Julia iteration. It's as easy as this thing, okay? But it is the only thing that allows you. Sorry?
The definition of max is max.
Yeah, thanks. So it's not all of you that are asleep. Fine. So max iter, okay? And after that, we have the iteration. We have something that builds the whole image. So we need something that has a width and a height. And I will call that thing, so this is already, I will call that Julia iteration. And I will make something that's called Julia set. That depends on a width, on a height. Depends also on the constant and this thing. You just forget about that max iter thing, something that's used to plot nice colors. And so first thing, we will create the image like an array. Has zero told what empty thing does? You tell them what empty does.
I think Alex talked about zeros.
So this is similar to zeros, but the problem when you have a matrix and you have to fill it with zeros is that filling a matrix with zeros takes time. Allocating an empty matrix takes less time. That's it. So why I'm doing int 8 here? Someone kind of suspicious why I'm using this strange type here? No? Yeah, colors. Colors are from 0 to 155 everywhere. So I'm going to make an image out of that. That's why they're integers. So and I will iterate that. Sorry. So I will import. Who knows about itertools? It's the greatest module of Python at all. If you don't know itertools, go right now and pick the itertools documentation and read it. Okay, it is great. JI induct range height width. So I'm iterating on the matrix, and Z is equal to I minus half of the width divided by half of the height. And I'm leaving and half of the 8, yes. And I forgot about this. Plus J minus half of the height divided by half of the height. This is pretty uncomfortable. Plus the complex constant. And finally m of ji, so I am trying to fill colors with iteration, is equal to iteration of z. Eh?
Why is it 1J?
Yeah, I probably missed something. Oh, 1j. This is the complex constant. Don't you know about complex numbers? Who here has never heard of complex numbers? Mathematics are great. You should never forget about them. Yeah, that's. I am aerospace engineer, so feel the pain. And here we have an array. Here I have an array that it gives. It's an array in which each element goes from 0 to 255. So I will use that to make colors out of it. Okay. Maxiter? It's M. Sorry. Thanks. And finally, I will make something that plots the image. So I will make something that's called plot Julia. That gets the width, the height, and I will split C in real part and imaginary part. And also I will use something like color map to plot the Julia set in different colors. And you will see now what I will do. And first thing that we'll do is that, okay, M is equal to Julia set of width, height, plus m plus 1 times 1j. So this is the C constant. And that's most of it. I will not put anything else. So, who knows about the getOut function?
Shouldn't be like in the formula where you are calculating set, the first term shouldn't be divided between y, no, w, hat. You are subtracting.
This one?
Yes.
No. So getOuter, I want to get the color map from matplotlib, but I don't want to get the full library. So what I will do is a trick, is that I will import CM, and from CM, I will get the color map like this. Just a trick. Okay?
Sorry, what did you import from Matplotlib?
The color maps, just the color maps, which is CM. Okay? And I will take, I will also import the rest of Matplotlib, so I will do PLT, and I think that that's it. And I will just try to plot that. So PLT imshow, that's used to just plot an image of M CMap. So that's equal to colors. Plot. I will change the axis. This is used to get the axis. So I'm just prettifying the image, okay? And finally, show the image, okay? And the same damn thing. So if name is equal to main, then plot Julia of, I don't know, 800 times 600 times, and then those numbers are chosen, so it creates something that's beautiful. And 0.156, and the column maps, I don't know, Inferno. Okay, and if we run this, we should get, it takes a while. On a hashable type list. CMap equal to colors. Oh yeah. I know what happened. I don't want this. So now, demagods, please, demagods. Yeah, we have a beautiful Julia set. Okay, and you cannot quite zoom in because the image has a resolution, a crappy resolution of 800 by 600, but we can create bigger things. Okay, so now we have a Julia set. Okay, it's as easy as this. Was that hard? Did it seem hard? No. Okay, so let's make it harder. Okay, how? Now we have an application that plots Julia set, something that runs in our computer. But okay, it's just an application. Just don't believe that. It's anything that takes a lot of CPU resources, something that keeps some time computing, and you don't know how much time it takes computing. And you see that's kind of intensive in CPU. And the problem of those applications is that those applications are for pirates. They pirate applications. And they're for cell phones if you want to sell them in the App Store. But applications don't make a lot of money. Services make money. Okay? So we want to turn that thing into a service because we want to get rich with Python or whatever. So we need a name for that if we want to make a good service. We need an elevator pitch to sell it to someone, and then a REST API to hire a front-end developer. Okay? And we will try to make something that works once an angel venture capitalist gives us, I don't know, 2 million euros, something like that. So we will call it Fractally, or now there's a lot of web pages that happen to be in Lebanon. I don't know why. The elevator speech will be fine building complexity. Web scale. Web scale is important. Venture capitalists love web scale. They want to be Google. And let's go for the REST API. Okay, so let's try to build a REST API that gets us Julia sets. Okay? So let's make it a little harder. So for that, who has ever used, who here is a web developer? No one? Sort of? Sort of, okay. Which framework do you use? No framework, so you type the HTML and really? Wow. I'm honestly impressed. I will use Flask, okay, because this is a live demo and I don't want to spend my life typing HTTP requests and all that thing. Okay, so we will create a Julia app. Okay, and we will start by importing Flask. Flask of name. So we want to test our API, so this is our API, okay? An API is something that gets some requests and gives some data to the program to run. So this is a little boring, so just, you can sleep now, okay? If I want to parse the request, I need to parse W. W, then I will put, I don't know, the file W, which is 600, else W is equal to W. I also need age. 400, let's make the image small. I also need the real part of the constant. I will put, I don't know, 0.8, 0.8, which is the one I had. Oops, not the 0. So now let's see if we really got to make something that looks like an API. So if we ever use Flask, so this redirects, handles the main page. True, this receives no arguments, and we will, I don't know, I will test it, okay? So I will return the variables. Who knows what I just did with that star here? Come on, someone answer to me. What I just did. Format asks for 5 values. So what I will do here is so it is something that gets 5 arguments, and I expand them here to something that waits for 5 arguments. This star is very, very handy, and once you become used to use Python, you will use it a lot, you will see. And the same damn thing ever, see?
You should import request also for Flask.
The?
Request.
Thanks. So now I have request. So now the same thing. Why we still do that? So why do we still do that? I don't know. I get angry every time they type this thing. And so now we have an API. Let's see if it works. So it seems that it works. It doesn't complain. Let's see if we can open a browser. If it opens someday. Yeah. So now if we go to localhost, 5,000. It complains that request doesn't have something called get. So let's go back to here. And it's like this. Forgot about this. So save this. We'll try it again. And we have an API. It's as easy as this. I don't know who has ever. No, there's no many web developers here. But if you ever have to do that thing in Java because your company uses Java, this is not that simple, okay? This is also a showroom of how easy it is to put APIs on internet when you use Python. It is that easy. How much time did it take to me? Like 10 minutes? Less than that. So this is something that I think that's brought Python to a broader audience, the fact that putting things on internet is so easy, okay? So given that it's so easy, I think that I don't understand why there are so few public APIs on the world. It's that easy that I don't understand how it doesn't happen that everything has a public API on the internet, okay? And after that rant, of course, this thing has nothing to do with the Julia set. So now we will connect our API to the application so we can have Julia sets in our browser, okay? So will that be difficult? Not really. So we'll modify that Julia app, and we will put some things in there. But we will need more things, okay? So we will start here with a new function. We will call it getImage. That depends on, you guess it, the width, the height, the parameters. We just made an API, so we just want to collect the values from the API and do some logic with it. So let me first start by measuring performance. And I will import that. Who knows about time? Time perf counter. I could have just said time or whatever. Why did I do perf counter? No one? Measuring time, if you want to understand the performance of your codes, measuring time is more difficult than you can think. I mean, it's not trivial, especially if you have different threads working at the same time. This is something that I think that's Python 3. It's not even present in Python 2. And that is at least a deterministic way of measuring time in Python, because the others are not, okay? So if you make time and whatever thing that's time and you're not using perf counter, you cannot trust the time that gets out of that, okay? Who learned something new? Fine. So M is equal to Julia's set of the with the height times 1j. And now, I don't know, we'll print the performance thing, so that by that image in seconds. Format with 8 end. Fine, we printed that, and now I will say, I mean, there's a curious thing. Matplotlib is great. Okay, it is fantastic. It's one of the most useful modules that you have in Python, but that it has an important inconvenience. It is designed to plot things and put them on scientific papers. Okay, it's not designed to make images, particularly if you want to make a large image. The Matplotlib will try to process it and make something that is printable. So if you just ask for an image that is, I don't know, 10,000 by 5,000 pixels, what Matplotlib will do is to make it civilized. It won't give you a huge thing of 10,000 by 5,000. So Matplotlib is not interesting if you want to make image processing. To make image processing, you have a beautiful model that is called Pillow that is imported like this. This imports something that is an actual image. Okay? Yeah, there. Thanks. Another one?
Also the return, the order of the parameters that you are returning in the punch request, you have to move
So now we need an image, and an image, if you ever work with working with images is beautiful. Images are just arrays, okay? They're just numbers. They may seem a lot tricky because they're compressed, but images are just arrays, and they're just arrays, three-dimensional arrays. So if I make this, this is an image of height, width, and 3 colors. RGB, red, green, and blue. And that's it. This is an image. I just made an image. That is it. Now we have to fill it up. Oh, this is another trick I have to make. Don't look at this, okay? Just to get the colors right. This is the most difficult part of it, so don't look that much of it. It's just to get something color. And I promise you that now image data is a real image. Okay, I used the data that I had in Julia's set to create a full-size image with all the data. Okay, and now image data contains, yeah? What is? I didn't hear you. M is this array here. So it's the Julia set. Okay? So now I promise you that if I make image from array, now I have an image. Okay? So I have the image data. I asked payload to translate that to an actual image. Okay? But there's a problem here. What if I do... What problem does that have? Come on, there's smart people everywhere. What's the problem of making just safe? Do I have a file system in a distributed system? Do I have a file system on a web browser? Do I really have it? No. I have no persistency, I only have memory. It's just an instance of a web browser. You can dump that thing on a temporary disk, but that's a really, really bad idea. So, there are many, many tricks. If you have something like this, an API like this that says, save that file, there is a very, very handy trick. Don't change that. You can save that, okay? But there's a module, a very handy module, that leaves you save things in memory, which is the I/O module, okay? Once you know about I/O, you just use it a lot, because it increases the performance of things by an impressive amount, because you don't touch the file system that is slow, okay? And the only thing that I have to do is to wrap that thing, that safe, that asks for a file, in something that is not a file, okay? So I have a stream that is IO dot byte.io, bytes.io. And now that stream thing is just like a file. It accepts the methods of a file. It's just a file, but it's memory. That's a good thing. So, image save in stream. I rewind the thing. Accept. And now I can return an image. So I have an HTTP request that returns an image. Okay? So the only thing that I have to do is change a little the website here, and instead of returning this thing, I can return an image. Make response.
There is a typo there. It's return equal.
Sorry, again?
The return in the function above.
The function. Thanks.
Equal string and equal.
Make response of image. And I have to say that that's an image. Otherwise, the browser will get crazy. And now I should have an application that returns an image. So let's test it. And it complains about Julia said in Gen image. You didn't catch that one. Julia said it complains about this. Yep. And I will make it like this, in fact. I will make it like this, so I'll make this. And I need matplotlib too. So now it should be fine. Okay, now I have a web app. Yeah, I forgot about all the modules. Come on, tell me. Now's the time. Come on, demagogues. And we have a Julia set in the browser. So we have a Julia set in the browser. What does that mean? It means that we can get rich out of it. We can make money, okay? So I will go to my slideshow, and we want to convince and blah, 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 blah. So now we have an application. But is it scalable? Not much. What happens if I have 2 requests? So one has to wait. Is it responsive? No. I mean, it's creating something that's 600 for 400, so this minuscule image. And how much does it take? Let me measure that. So 1, 2, 3, 4 seconds. Come on, that's a small image. Imagine if one asks for an image that's bigger than that. I don't know. Let's make like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm wasting your precious time, I know. That takes ages, basically, and that's it. So it takes like, I don't know, 20 seconds. So is it responsive? No. Is it efficient? No. Okay? No, at all. And I know. So what do we do now? We want to make it more scalable, more responsive. By the way, those 3 questions are important. Every time that you have a distributed system and you want it to perform well, you make those 3 questions over and over and over again. If you fall short on any of those, basically your system sucks. Okay? So let's start by making it more responsive. Okay? And let me start by copying something. Okay? So when you have a problem of performance, what everyone tells you is that, okay, you should write an extension. Python is slow. So write something in C or in Python or in whatever, something that runs faster, okay? So what I will do, I have an implementation of the Julia set written in Python that is way faster, okay? Imagine that I start typing, I develop that, and I get it. So I don't know, I mean, CP projects PyData stage 8, because it's in the stage 8. Julia fast. And I have an extension written in Python. Who knows about Python? Python is just a way of implementing something in a Python-like language. It's a different language. It's not Python. It's something slightly different that translates to C++. It compiles to C++, turns it into a time-loadable module that you can load at runtime. Lots and lots of magic happens there, and you're faster. So it's great. Problem is that you have to compile it. So I have to compile things, so Pythonizing things, a lot of crazy stuff, warnings everywhere, but you get a fast version of the Julia set. And the only thing that you have to do to get a faster Julia set is go to the Julia application and make this. that's it. Now I have an application. I'll go here and 1, 2, 3, 4. That's it. So I'm 4 times faster. Come on, an applause. Come on. Thank you, thank you, thank you, thank you. That's it. So let's back to the presentation. So we're making that thing a little more efficient. We're using the same CPU, we're using the same resources, and it's just faster. And now, since we have a very fast implementation of the Julia set, we visit the business angel and we get some money. So we can rent real servers. We don't have to run on a laptop anymore. Okay? So let's make it parallel. How? Okay. An important thing, I've worked so much in parallelization during my life. It is a hell of a job. There is nothing harder than solving a Rubik cube blindfolded than debugging a parallel system. It is a nightmare, okay? But if I have to give you 3 simple rules once you decide to use more than one server, those are my 3 pieces of advice. The first one, parallelization is about splitting things, okay? And the less amount of information each split part shares, the better, okay? Because if the things, you have to start sharing things between jobs, you find yourself in one thing called the cap theorem. I don't know if anyone here knows about the cap theorem. Okay, cap means C is for concurrency, A is for availability, and P is for partition tolerance. It means that you cannot have something that is parallel. You cannot have only of those 3 things. So you cannot have those 3 things, so concurrency, availability, and partition tolerance at the same time. You have to choose 2 of them. Okay? And that's a theorem. It's proven. It's not some crazy Web 2.0 idea. No, that's mathematics. Okay? And the most important thing is that you exploit low-hanging fruits. If something is really parallel, just use it. You're not writing a paper in computer science. You want to get rich. So, shortcuts, okay? Shortcuts, all the time. So, internet is parallel this way. Everyone uses reverse proxies. Who has ever seen this thing before? So, who has never seen something like this in their life? Never. So, I understand that most of you knows how this works. Yes or no? You're asleep. Come on. So I understand that most of you know how that works. So how do I do a reverse proxy from my application? Does someone know? Parallel stuff. No? It's very easy. It's that easy. I just need to write a file. Who knows about WSGI? More or less. Do you know what WSGI is? WSGI is a standard way, and this is something that's great about Python. Python, if you want to write a web server, if you want to write something that talks to a web server, there is a standardized way of writing things. This is something that I think that only Python has. So it is great because you don't have a million technologies on how to communicate with a web server. There is one. That's why Python is so great to write web applications. Because you can switch your application, you can switch completely to the web server, and it will work the same way. It's great. Okay? So that's why I think
Isn't this what you use in Heroku to deploy?
you use it everywhere. In an app engine, you use WSGI. You use it everywhere because it's a standard. Okay? And it's a low-level standard, and it's great. That's why, not because of Django, not because all those things, not because of frameworks. The reason why I think that Python is picking momentum in web development is because of that. Okay, so now I just write the configure stuff. So HTTP socket is 5000, not to change stuff. I need a Python plugin. I need a Julia app. Master is equal to 2. And now my application is parallel. It's been easy, isn't it? So now, instead of running this thing like this, I do this. And socket, it's complaining because of sockets missing. It's the, oh yeah, I know it's gonna. It's because this things like this. So now I have 4 workers. And if I open another request, it handles that request in parallel. So now I have a parallel system, a true parallel system. And what did I do? Write a configuration file. Okay, was that hard? I don't think so. Okay, but of course problems happen and people's never happy. So is it scalable? Is it scalable? Yes or no? It is scalable. I have more workload, I just add more workers. It is scalable. Is it responsive? I didn't make it any more responsive than it was. Maybe if I have to request at the same time, I have more way of load balancing, but a single request is not more responsive. Okay? Is it efficient? Just as efficient as it was. I haven't changed anything about that. I only made the application parallel. Okay? So I deploy that because that's a good way of getting users. So you deploy that. And the first users complain the application is not responsive enough. So user response is the most important thing. So if users complain, it's not because the user is stupid, it's because there's something wrong. Okay? So we hire a front-end developer and we'll try to make the application asynchronous. So we can finally hire a front-end developer. And we will do that old school like. Who has here worked with threads? Not many people. Who here doesn't know at all what a thread is? You don't know what a thread is? Anyone else? So the rest knows what threads are. Okay, so you just send the execution to something that runs somewhere you don't know and get control back. Okay, something, just a way of making things asynchronous. Fine? So let's make our application asynchronous. So what we really want to do, is something as simple as this. I import something to launch a thread. And here, instead of just calling gen image, what we want to do is this. And we launch that in a thread. Okay? But that has a huge, huge issue. Okay? How do I get the result? That's a problem when you make things asynchronous. When you make things asynchronous, the problem is moving memory around. The thread has no control. You just launch it. How you get the result, how you get the image. And that's why when the applications are asynchronous and you start communicating things a lot, you need a database. Until now, we have not needed a database. Now we need one because we need to talk to that thread. Because once we just launch that thing that thread thing, we have lost control completely. Okay? So this is important if you ever use threads and want to make things asynchronous. Once you make threads, you make things asynchronous, you lose control. Okay? That's one of the things that you have to have, I don't know, tattooed beside your heart, something like that. So, we need a database. Yep.
That line, I think the parenthesis was wrong. You have to move after Guillem, you have to move the parenthesis to the end.
Yeah. So I will go with that. Thanks. I will go to that line again. Okay. So now I need a database. Okay. And the simplest database you have, and it's a module that's not very known, is Shelf. Shelf is a key value database that all Pythons have. Okay? It's a very interesting module. Let me go to my notes. Get any image store. Yeah, so I have Shelf. And I need, with the application, I need a data store. So store is equal to Shelf. Open, I don't know, a file. Now I have persistency. Now I can save things to disk. Now the threads can give a result. Threads just communicate when they're finished. They go to the database, they save it. And sometime I will fetch that, fully asynchronously. Okay? So now I have a data store. But the problem is that how do I know what thing I've saved in the database? I need to give a key to things. I have to put them on a table. I have to identify them somehow. And there's another handy, very, very handy module in Python called UUID. This function here returns a unique ID for every time I call it. And it's long enough so it doesn't return two identical IDs and say until you run it for the age of the universe, something like that. Okay? So with this, I have persistency. From this, I know how to get things from the database. Okay? That's the necessary thing. So we get on. Now we launch the thread. Okay? We launch the thread. Where's the thread? Where's the thread? Yeah, here. We launch the thread. The target is the same function, image. And the arguments, we need something else. Okay? So we need to modify slightly the API. So here we need a key. So we get the unique ID. And here in GenImage, I have to modify that slightly to get that key. Okay? And at the end of that, instead of saving it, instead of returning it, I save it in the database. By the way, shelf works just like a dictionary, so it's very handy. Okay, you have a persistence mechanism, you have a database that just works like a dictionary. So it's very cool. So now I have that thing in the database, and I'm happy because I know how to communicate with threads now. So GenImage, and at the end of that, if I do, I have to do this key, of course. After that thread finishes, it will save things to a database, and I will be able to fetch that because I have the key. Okay? So, and I think I need an extra parent here. Yep. And the only thing I do is that instead of image, I call it image thread. And I do the image thread just in case. And I start the thread. Okay? So that's it. I just launched the thread. But the problem is that... Yeah. Thanks. But the problem now is that what do I do with that? Yes?
You call image thread and ing.
Yeah. It's because I'm just like Rajoy. I don't understand my own. So the problem is that, okay, now if I launch the thread and then I get the result here, that thing is just as synchronous as it was. So I go here, I wait for the thread, and then I return the response. No, that doesn't make sense. Okay, so I will split this. And I will split this into something like root and something like, okay, like this. So I'll split that into functions. Yeah. And it's like this. Like this and like this. Application root, so is that okay? Yeah? No? Oh, the A. Oh, that was a camouflage A. So this now can return the response. So here, what I do after thread is I will return something. Something that to make the user happy. Okay, and I will return that thing and say, and I don't know, click here. Click here. Yeah. And I will point that to the other thing, the other URL. Okay, this thing is as easy as saying so we'll split that. Split this and this and this and this, and I will say key, and I think that that's fine.
You don't need the driving plus backslash because it is automatic, even the plus. Yeah. I think it's much more readable.
Okay, thank you.
But that depends.
Oh, now you broke my indentation.
No,
That's because Emacs is a little stupid. No.
You probably no, you can put a parenthesis at the beginning. Return parenthesis. Yeah, and then.
Oh,
Yeah.
nice trick.
That's a hex editor. You shouldn't use hex editor.
So now what I will do is that I will turn that thing into very, very, very asynchronous, okay? So key. Thanks. Store self if image. If image, I will just return that. Else, and I will say, I'll copy that.
I'm thinking that perhaps this won't work because you have the dot format, and perhaps the Python interpreter is not able to join the different.
So
You know what I mean?
yeah, so let's do that. It's fantastic. I'm right even when I'm wrong. Oops. So now, let me put that to the same URL, and I'll put something like not yet. Not yet. So now this thing is fully synchronous. Okay, let's check if this works. Yep.
Is any shell with PE instead of that?
Yes, shelf. You're right. So let's. Eh?
You have not required return. Because you're returning the rest of the
Yeah. Yep. So.
that was the one after before the else.
You're returning it twice.
Thanks. So let's see if that works. So now, in theory, now when I make the request, as I've launched that in a thread, the application should return immediately, give control to the user, so make that thing of click here immediately, because it is in a thread. I made my application asynchronous. Okay, did I? So let's try it. Let's see if it returns an error or not. Oh, sorry, I have to start that. So I start my application and I try this, okay? And it doesn't. It takes a while. Let me check for something bigger, okay? I don't know, 4,000 times 2,000. And it takes a while, waiting for localhost, waiting for localhost, waiting for localhost. It's not doing anything. It's not doing anything. It's like 5-6 seconds, and it's not doing anything. But I made my application asynchronous. And now it's returning. So I've launched a thread. I spend your precious time making the application asynchronous, and it's not. So what is going on? Someone has just a light idea of what is going on? So at least this is surprising. Okay. So by the way, user side, you've seen that user side that just made polling. So click here. Just ask someone to click here. It may be dull or whatever, but I gave the control to the user. Okay, that's important. User always have to have the control. Okay, but again, and that's a curious thing, the application is not as responsive as we expected. We did everything right, and the application is dead. And we are confused. Okay, you know what is going on here. This gentleman here is called David Beasley, okay? The thing that has on in front of him is, yes, you see, is GIL written in wood. What the GIL is, I mean, once you find yourself reading of GIL, you must listen to his talks. The important thing is that the global interpreter lock is the fact that there is just one thread running at a time, okay, causes real performance effects, okay? You think that you're launching a thread, but you are not. Python has something called global interpreter lock, for which only one thread is running at a time. If I ask one thread to compute an image, the other thread that's trying to respond to the request will be dead, okay? But that's something even more interesting. If I go back to my application, and I make this, and I ask for the exact same thing, now it returns immediately. And now we're even more confused. The application is slower because I took the extension away. Now everything is pure Python. And now for whatever reason, the application has improved the responsiveness. And now we're really confused. Okay? This is something strange about how the internals of Python work. Okay? There is only one thread running at a time. And if one of those threads is very efficient, like the one I had, the one that computes the message, if one of the two threads is very efficient, it destroys your responsiveness, which is kind of contradictory, but this is how Python works. Okay? You can do anything about that. Because the problem of the global interpreter lock is that it is there because it has to be there. It makes the language simple. Okay? It makes it simple to extend. But the important thing about that, and it's something that you have to have in mind when you start mixing threads, is that you should never, in the same process, put a thread that's doing some kind of I/O, like listening to a request, with, in the same process, another thread that's hammering the CPU. Never, ever do that. Okay? Never. Because you will have problems of responsiveness. And this is when things start being really complicated. The only way in which, I mean, this is particular of Python, okay? Java doesn't work that way. C# doesn't work that way. Java is, you can do that thing in Java. You can do that thing in C#. They have virtual machines that can handle this kind of workload, but not Python, okay? But the problem is that when you do that kind of things, you cannot write extensions. Python is perfectly happy handling all that heterogeneous workload if all the code is written in Python. The problem is when you try to make crazy things there. Okay? The only way of solving that, now there's people that when people start knowing about the GIL, everyone gets completely crazy. The GIL is the worst. You have to remove the GIL. The GIL makes Python crap. It's not like that. But it is true that when the GIL affects your performance, you're in trouble. Because the only way of solving that is separating I/O from, so the response, from the CPU load. And you get into really complicated architectures. The only way, or the most practical way of solving that, is putting your response in a front end. Okay? And your computation in a back end. And maybe the simplest thing, this is the shelf, the whole database, okay? The simplest thing to connect the front end and the back end is through a broker, okay? I don't have the master time, and I don't know how much time do I have.
It's 20 minutes.
20 minutes. Okay. And this thing, there are companies that are worth billions that don't have an architecture sophisticated as this. So we're talking about serious things here, okay? So this is a multi-process, brokerized, distributed thing with a reverse proxy and a broker. This is fantastic, okay? The problem is that you need a broker, and we need message passing. The problem is to communicate the processes, and that is something that is not difficult, but is not trivial. The way to communicate processes in Python, there are many ways. But what I think that's the way that beats all the rest is a message queue called zerom queue. If you ever do distributed systems in your life, use that. I understand that someone may not agree with my opinion, but I think that's kind of an educated opinion, okay? I've worked with zerom queue and I think that is great. Not only the library, but also the Python bindings to zerom queue. Zerom queue is written in C++, and the Python bindings are great. C++. C++. It has a wrapper to C, but the library is in C++. And it's great. And by the way, one of the creators of zerom queue, that's Peter Hintians, I don't know if you pronounce his name right, gives great talks. So you also have to listen to him. And if you have a message queue, you also need a message protocol. And in this case, I will use JSON. It is the crappiest message protocol that there is, but it's simple. And in this case, I will just use it, okay? But in real life, don't use it, okay? The good thing of JSON is that it is human readable, but machines are not humans. Remember that, okay? and a database that is shelf. Okay? So, we will go for this architecture. That is, again, I said, pretty crazy. But it's doable. And let me, since I want then you to make some questions and maybe you're tired, I will just copy the broker. So I will go to So, as you've seen here, and now this will be a little more boring because I'm not live coding anymore, but I'm running out of time. Getting a broker to work in Python and in ZeroMQ is not that complicated. Okay, it is, I don't know, like 55 lines of code. It's very, very short. By the way, and you can copy paste that from the ZeroMQ documentation. That's shamelessly copy pasted from the documentation. Okay, I modified it a little bit, but it's really copy pasting. This is, I mean, the documentation of ZeroMQ for Python is that good. Okay, and it's easy. I mean, the good thing, the most important, and now because people is kind of crazy about I/O libraries. Have you heard of async.io? Python 3, async await, all the new things that are added to Python that no one knows how to use properly. The good thing about ZeroMQ, and I say that that's great, is that it comes with its own event loop. So you declare a poller, you register a socket to the poller, and then you just poll. And when that socket gets any message, it unblocks. Okay? So if you don't understand async.io, don't worry, you don't have to use it. There are alternatives to it. Okay? This is not a message that you have to have. And maybe you have not understood many of this talk, but you have to understand the messages. The fact that a module it is on the standard library doesn't mean that you have to use it. There are a million alternatives. And since async.io is so difficult to use and so difficult to understand, come on, something that a coroutine that waits from a generator, you get crazy trying to understand that library. But the good thing is that you don't have to use it. You have to learn the concepts that are from it. And this is much more simpler. You just use a poller that listens to a socket. That's it. And the good thing is that this is so simple and so handy that you can build something as difficult as a broker in 50 lines of code. Okay? So this, of course, means that you have to change a little your front end and your back end. Because the front end and the back end have to communicate not by themselves, but they have to communicate through a broker. The changes are not that aggressive. This is the Julia app. I turned that into a front end. There are context, something that is ZeroMQ, but at the end, the whole thing is not longer than this. I just changed the gen image to something called remote image that wraps the arguments, just wraps the arguments of the call, creates a message, a JSON message, okay? Sends the message, it will go to the broker, the backend will do something, it will go again through the broker, and we will receive the message. Close the socket, and that's it. Okay? And of course, we need a backend. And the backend is a little complicated, but it's not really crazy complicated. Of course, you need sockets because you're communicating. But I just moved the gen image and added this thing here. Gen image is the same function, and I just made a small daemon. I receive the image, the data from the broker, just decode the message, generate the image, and send the image back. It's not that complicated, and it's parallel, and it is asynchronous. Okay. So instead of running the application up in running, I will try to run this new application. That is, you've seen a broker, front end, back end. It seems crazy, but again, it's something that you can code in 2 hours. So what I will do is that I will start the broker. Sorry. Start a backend. Oh yeah, I have to compile it, sorry. Stop build. Julia backend, and it's listening. And we have a front end. We have all the pieces, so let's see if that works. Oh, of course it worked. I tested it before, but... And click here, and it returned it immediately. And we're using the Python version, but it, of course it returned immediately. The whole thing is running on a different process. So let me just, as it take 20 seconds, let me do that again, okay? So I ask for something, okay? I ask for an image, okay, now. And I go to the backend. And it's working, and it's working, and it's working. And it takes like 14 seconds. It will get the image eventually. And it gets the image, gets through the broker, gets to the front end. And we have it. And you see, now we can start creating things really, really, really big. Okay? So,
what's the
yeah.
sequence of comments you have used?
It doesn't care. You can start the broker first, or the... You don't care. That's great about ZeroMQ. You can have something that's binned and something that is connect, and it doesn't care which start first. It's great. I mean, if you ever code with sockets, it's crazy. I mean, ZeroMQ solves a million issues. So it is scalable. Come on, say yes. It's not that hard. It is scalable. The only thing that I have to do is just to send more front ends. More backends. I can launch 1 or 1 million backends. I don't care. The broker just sends messages. It's fine. Is it responsive? It is responsive. Okay? It is efficient. It is efficient. It's not more efficient than it used to be. It is efficient, kind of efficient, but we still have this Python implementation. Can we go faster than that? Can we go faster than Python? Can we? Well, you can. If you use Julia. You should try Julia, it's great. Okay? Basically, this is the same backend, instead of written in Python, written in Julia. And it is not very, very different. It's a little more verbose, but not that much. No, a little. I mean, don't look at the line here. I mean, this is part of that line. That thing is rubbish because I have to put the color map here. But it starts in line. It's all the functions. It starts in line, I don't know, 73. And finishes, I mean, it is 70 lines. And is it faster? You've seen 14 seconds previously. So instead of opening the Python backend, I will open the Julia backend. Sorry, I will kill everything. So I will start the broker. I will start the Julia backend. Oh yeah, Germ cannot find the path. I have to install it. So I think I have to make the Julia. It was package add, something like that. Package add, I don't have it. Package. I think that was package. Term queue. Sorry. Oh, by the way, Julia has this thing. So this is a string, the other is a string literal. Little annoying. How much time do we have?
Well, a little bit more than 5 minutes.
So while this is compiling and stuff, questions? Is your brain fried or something like that? I would be. Yeah. No, because my time was pretty limited too, so I wanted to experiment a little bit with Julia, and I decided to put Julia instead of, but not because of any particular reason. Number, I know that number is great. I know that it's great. If you, Juan Lu did up several posts of number in Fibonacci, I think. Probably you've read them. I don't know. More questions? Package add was file.io, I think.
There is some reason why you didn't try multiprocessing instead of multi-threading to avoid the guild, I mean?
It's a good way of avoiding the guild, definitely. But the problem of multiprocessing is that you're bound to the same node. You can launch multiple processors on the same physical node. If you want to go fully distributed, in this way, you can escape a single node. So you can deploy in Google and 1,000 servers. It is a good idea if you know that with a node. No, this is a good point. I mean, multiprocessing is great. It is really great. I use it a lot. And it's perfectly fine if you know that with one node will be enough. Okay? So let me see if I have all the packages. Julia, images, file.io.
It's very much like this example. So you can follow it exactly. Yeah, but there is nothing fundamental about Cython not reaching the performance of Julia. I mean, it's a matter of time.
The problem of Cython, what I found, is that this Cython script was kind of quite carefully written, so it was not wasting performance. The problem of Cython is that it depends a lot on how you write your code. You can do many things that, for whatever reason, kick the Python interpreter in, and you waste a lot of time.
Actually, it's like a two-part part because the first one is part of it is profiled.
Yeah, I mean, it is.
And also there is an interesting.
But as you said, just look at the size of product.
I mean, in Cython you have this qualifier which is called no guild, that ensures that all the sentences that you are writing in this under this qualifier are exactly translated into C without going into Python space. So this is a quite safe way to develop in Python if you are going for speed.
So if you remember, that took 14 seconds, I think, in Python. Sorry. Oh, and JSON. Oh, damn. Damn. Okay, now. Let's see if now. So it took like, again, 14 seconds. So I have the request here. Image magic. No. This is tedious, I'm sorry. I have Image Magic installed. Okay, whatever. Why doesn't, what, it's not working. Who cares? The thing is that if you don't code your program in Julia carefully, you get a speed of like of 4 respect to Python, not very carefully written. So that those 14 seconds get down to 3 point something. So I understand that this is a conference about Python, but the message here is that don't get too close with the Python thing. One of the important things of distributed systems is that once you have paid the huge amount of effort that you need to distribute your systems, is that once it is perfectly distributed, it doesn't care what language you use, because you're just passing messages. You can communicate Python with Julia, or with C, or with Java, with whatever. You don't care. So the good thing about distributed systems is that after you've done all the work, you can get unexpected good things from it. I understand that what I've said here is, I mean, it takes some effort to understand, but if you get a message from the stock, is that it is not that hard. Okay, if you know the basic tricks, and I try to explain the basic tricks, it's not that hard. Okay, so finished.